Okay, picture this. It's like the mid to late 90s. You've just gone through that whole dial-up ritual, the screeching, the static. Finally, you're online. The World Wide Web.
Yeah.
And you want to find something specific, maybe, I don't know, some actual official info about the president. So you type it into one of those early search engines, hit enter, and what do you get? Maybe a joke website pops up, or like a fan page, or worse, these pages trying to trick you, right? Clicking ads, downloading who knows what. It really was this digital Wild West, just this huge, messy ocean of information, but no reliable map. You were just lost.
Totally lost, exactly. The amount of information, it was just growing exponentially. It's hard to even imagine now. But yeah, finding anything high quality, it was like searching for a needle in a haystack that was doubling in size every day, basically. The search engines back then, they were just drowning, completely overwhelmed, low quality matches, even, like you said, deceptive stuff. It was a real problem.
And that is exactly the landscape, that sort of chaotic, exciting, but frustrating time we're diving into today. We're going back to 1998 and looking at this truly monumental research paper. Seriously, it changed pretty much everything.
Welcome, everyone, to Computer Science Tech Papers Summary. I'm Jordan.
And I'm Alex. Today, we are unpacking Anatomy of a Large-Scale Hypertextual Web Search Engine. It was written by Sergey, Brin, and Lawrence Page, who were grad students at Stanford at the time. And look, this isn't just some dusty old paper. It's basically the blueprint for the internet search we use every single day. It laid the groundwork for Google, obviously, but also for how we even think about finding information online. Foundational stuff. So, okay, let's set that scene a bit more. What was the core pain point? What were Brin and Page really staring down in the mid-90s? What was so broken?
Well, it really came down to two big things, scale and quality. Mostly scale, initially. Just look at the numbers, kind of mind-blowing. In 94, you had one of the first search engines, the World Wide Web. Quaint name, right?
Yeah.
It indexed about 110,000 pages. Sounds like a lot then, maybe. But fast forward just 3 years, November 97. Things had exploded. Web crawler claimed like 2 million documents. Alta Vista, which was a huge deal then, was boasting 100 million documents. And they were predicting over 1 billion documents by the year 2000. That's an insane scaling challenge, from thousands to potentially billions in just a few years.
Oh, 1 billion. That's going from managing maybe a small-town library's collection, carefully picked books, to suddenly being handed the keys to the Library of Congress, millions and millions of items, and told, okay, organize this.
Yeah.
And, oh, by the way, thousands of new books are appearing every single minute. But it wasn't just the sheer number of pages, right? It was also about what you found, the quality, the relevance.
Not at all. Yeah, the quality was maybe the bigger frustration for users. The paper itself points out that users back then were often inexperienced in the art of web research, which basically means, people type simple queries. They weren't doing complex Boolean searches, and they definitely weren't going to scroll past the first page, the first few tens of results, as the paper says. So if that first page was just junk results, they called it, or low-quality matches, the search was useless. Waste of time.
Right, like our Bill Clinton example. Finding a joke site when you need actual government info, it sounds funny now, but imagine needing that for school or work. It was genuinely frustrating. It made you question if the web was even reliable for serious stuff.
Absolutely. And compounding that was the web structure itself. It was, and still is mostly, these uncontrolled hypertext collections. Anyone could publish anything, no editor, no filter, really. So naturally, it got messy. Unreliable information, sure, but also intentional deception. The paper saw it coming, noting some advertisers attempt to gain people's attention by taking measures meant to mislead. Sound familiar?
Oh, yeah. Some things never change.
Right. So this wasn't just noise, it was active manipulation trying to game the system. And all this created this urgent need for a totally new way to search, something that could actually find quality and relevance in all that chaos. And it wasn't just the number of pages exploding, the number of searches, the queries people were actually doing was also going through the roof. Remember the World Wide Web worm? Back in early 94, it got maybe 1,500 queries a day. Seems tiny now. But by late 97, Alta Vista, they were handling around 20 million queries every single day. And the projections for 2000 were like hundreds of millions per day. It was just a different world of interaction.
Yeah, that's not just like more people using it. That's a fundamental shift in how people expected to interact with information. It's like going from that quiet village, well, a few people drawing water, to this massive city waterworks trying to supply millions, all demanding clean water right now. And the existing pipes, the existing search tech, it just wasn't built for that kind of pressure. It was starting to crack.
Exactly. The main method was just keyword matching. Simple, yeah, but just not precise enough for the messy, huge web. You search Apple, you get the fruit, the company, maybe Gwyneth Paltrow's kid, who knows, no context. Then you have the human curated lists like Yahoo, directory. Useful maybe for finding, say, Ford's website, but they were subjective, expensive to maintain, slow to update, and couldn't possibly cover everything. All the niche topics, forget it. Plus, the paper pointed out that commercial search engine tech was becoming this black art. Companies kept their methods secret, which, stifled research and understanding in the academic world.
Huh. So this paper, it wasn't just about building a better search engine, which, spoiler alert, they did. It was almost like a statement, a deliberate push to bring search engine science back into the open, into academia. They actually said they saw Google as a space lab-like environment for research, like a place others could come and study the web. That's pretty cool. That opens science thinking right from the start. Sharing the knowledge, not just building a product.
Okay, so Brin and Page are facing this monster problem. Huge scale, messy content, exploding usage, creaky old tools. What was their big idea, their fundamental insight that just cut through all that complexity? What was the core innovation?
Well, their main goal straight up was to improve the quality of web search engines. That was priority one. And they focused on two really important features that other engines were basically ignoring or underutilizing. First, the link structure of the web, how pages connect to each other, the hyperlinks themselves, and second, the anchor text. That's the clickable text you actually see in a hyperlink. These two things, the links and the text describing them, they realized held the key, and boom, enter PageRank. Right? This is the legendary concept. It's almost like internet mythology now. But back in '98, in the paper, how did they explain it? What was PageRank? Fundamentally.
They used a great analogy. They called it an objective measure of its citation importance, drawing right from academic publishing. Think about it. A research paper gets cited by lots of other papers, especially important papers. That original paper is probably pretty significant. They applied that idea to the web. A hyperlink is like a citation, a vote, kind of. But crucially, and this was the genius part, they realized not all votes should be equal. Some links matter more than others. A link from, say, the New York Times website should count way more than a link from some random GeoCities page. It wasn't just a simple count.
Ah, okay. And then they explained it with the random surfer model. That's the analogy everyone remembers, isn't it? It makes the really complex math behind it feel intuitive, relatable.
Exactly.
Yeah.
It's a brilliant model. Imagine this hypothetical surfer just randomly dropped onto a web page. They start clicking links on that page, following them, never hitting the back button, just clicking forward. But eventually, our surfer gets bored. At any click, there's a chance, instead of following another link, they just randomly jump to a completely different page somewhere else on the web. The probability that this random surfer, over a long time, ends up on any particular page, that's its PageRank. And that chance of getting bored and jumping, that's the dampening factor. Usually set around 0.85 or 85% chance they follow a link, 15% chance they jump. This stops pages getting stuck in loops and makes the whole model work mathematically, reflecting how people actually browse.
Okay, got it. So a page is important not just if lots of pages link to it, but if pages that are already important link to it. It's recursive. It's like a network of trust. A recommendation from a well-respected expert means more than a shout from a random person.
Yeah.
That's really elegant.
Precisely. And the second huge piece was anchor text. This was another, again, seemingly simple idea with massive implications. Before Google, search engines mostly looked at the text on the page a link was on. Brin and Page said, wait, the text of the link itself, the anchor text, tells you something important about the page it's pointing to. They decided to associate that anchor text with the destination page.
That makes so much sense now, but it must have been revolutionary then. It means if I link to your site and the link says best explanation of PageRank, Google understood that your site was about the best explanation of PageRank. Even if those exact words weren't like plastered all over your page, it uses the collective wisdom of the web creators.
Exactly. And the advantages were huge. Anchor text often gives more accurate descriptions than the page itself, especially for non-text pages or poorly written ones. And, get this, it could even help you find pages that hadn't actually been crawled yet or couldn't be crawled easily, like images, programs, databases. If someone linked to mycoolprogram.exe with the anchor text useful file utility, you could potentially find that program by searching for useful file utility, even though the search engine couldn't read the program's code. They indexed over 259 million anchors from their first big crawl of 24 million pages. That's a massive amount of descriptive data they unlocked.
Well, Okay, so PageRank and anchor text, those are the conceptual breakthroughs, but you called the paper anatomy. So what did the actual system look like, the architecture? This wasn't just an algorithm, it was a whole machine, right?
Oh yeah, a complex distributed machine, built mostly in C and C++ for speed, designed specifically to scale well to extremely large datasets.
Hmm.
That was key. And they had to be incredibly smart about using resources, especially storage space and disk access. Disk seeks moving the physical read head on a hard drive were super slow back then, maybe 10 milliseconds each. Sounds fast, but multiply by billions. So they optimized everything to avoid disk seeks whenever possible, keep data together, read sequentially. Real engineering grit.
Okay, makes sense. So let's trace the journey. A web page exists out there. Googlebot decides to crawl it. What happens next? Walk us through the pipeline.
Right. First step, web crawling. They had several distributed crawlers, all coordinated by a central URL server. And interestingly, the URL server and the crawlers were actually written in Python, which was pretty forward-thinking then, using Python for flexibility. Each crawler kept about 300 connections open at once, just constantly fetching pages in parallel. Super fast for the time. They were hitting speeds of 100 web pages per second with just 4 crawlers. That's how they could grab millions of pages a day. And they even had those funny social issues, webmasters emailing them asking things like, "How did you like my site?" after the crawler visited. Shows how new this massive crawling was.
Ah, that's amazing, getting fan mail for your web robot. Okay, so the pages are fetched. Millions of them. Where do they go?
They go to the store server. Its job is simple. Compress the HTML and store it in a big repository, like a giant digital warehouse. Each page gets a unique doc ID when its URL is first seen. That ID is its internal name tag. Next up, the indexer. This is where the parsing happens. It grabs pages from the repository, uncompresses them, and it breaks each page down into hits. A hit is basically every word, plus its position, its font size as a proxy for importance, and capitalization, all that metadata. These hits get sorted into temporary bins called barrels, creating what they termed a partially sorted forward index. Think of it as organizing by document first. Crucially, the indexer also pulls out all the links from each page, along with the anchor text, and puts that into a separate anchors file.
Okay, so the raw ingredients are being chopped and sorted. Words identified, links extracted. How does it start to come together into something searchable?
That's the URL resolver. It takes that anchors file full of linked data, it cleans up the URLs, making them absolute, finds the doc ID for each linked page, and here's the anchor text magic. It takes the anchor text and adds it to the index information for the page being pointed to, the destination page's doc ID. So again, if lots of pages link to whitehouse.gov saying President's website, that site effectively gets tagged with President's website keywords. The URL resolver also creates the final links database, mapping out all the connections, which is what's fed into the PageRank calculation later.
Got it. That links database is the key input for PageRank. And then
Yeah.
finally, the actual searchable index.
Almost there. The sorter takes those barrels from the indexer, which are sorted by docid, and it flips them around, resorting everything by worded to create the inverted index. So instead of document words, it's word and documents containing that word, plus the hit info, position, font size, etc. This is the core structure that lets you instantly find all pages mentioning platypus, for example. Super fast lookups, they did clever in-place sorting to save disk space, which was critical. Finally, a small utility called dumplexicon creates the lexicon, basically, a massive dictionary of all unique words, mapping each word to its place in the inverted index. And the searcher, the actual web server you interact with, uses that lexicon, the inverted index, and the pre-calculated page ranks to answer your query, ranking the results.
Wow. That is an incredibly complex, yet beautifully logical assembly line designed purely for scale and efficiency using 90s tech. Just amazing engineering. So, okay, they built this incredible machine based on these brilliant ideas of PageRank and anchor text. Did it actually work? Did it deliver better results? What did they find?
Oh yeah, big time. Subjectively, they just found Google gave higher quality search results than the major commercial search engines for most searches. It just felt better. And they had concrete examples, like the Bill Clinton search we keep mentioning. Other engines gave jokes, random stuff. Google returned pages from whitehouse.gov, the official source. That's what people wanted. Huge difference in relevance.
And not just the main White House page, right?
Yeah.
It found really specific, relevant stuff, sometimes purely because of anchor text,
Yeah.
or even things that weren't web pages.
Exactly. The paper points out, for that Clinton search, the first result had no title itself. It ranked high purely because of good anchor text pointing to it. And the fifth result, it was an email address. which normally a text crawler can't even index. But someone had linked to it with a relevant anchor text, so Google found it. That just perfectly showcased the power of combining PageRank, anchor text, and also looking at word proximity if query words appeared close together. That boosted relevance. They were finding needles other engines didn't even know existed.
That's incredible. Quality win. Check. What about scale and performance? How fast could this thing actually run back in '98? Those numbers must have been impressive too.
They really were, for the time. The crawling after optimization hit 11 million pages in just 63 hours. That's over 4 million pages per day, around 48.5 pages per second. Just flying through the web compared to anything before. The indexer processed pages at about 54 pages per second. And the sorters, running on 4 machines in parallel, could sort that massive inverted index data in about 24 hours. Showed their distributed design worked well. They could process data incredibly fast.
Mind-blowing speeds for the dial-up era. And storage. How much space did this digital beast take up? Hard drives were tiny then.
For their 24 million page index, the total storage, including the compressed page repository, was 108.7 gigabytes. Just the searchable full inverted index itself was 37.2 gigabytes. Which, yeah, was enormous then. A typical home PC might have had a 2 or 4 gigabyte drive, maybe. They managed this partly with their custom big file system. Basically, a clever software layer that let them treat multiple smaller physical disks as one giant virtual disk. It supported compression, too, essential for handling that much data.
Ingenious. And the user experience. Query times. How long did you wait for results?
Most queries came back between 1 and 10 seconds. Which, okay, not the milliseconds we expect now, but pretty good for '98. They did note, though, that speed was mostly dominated by disk I/O over NFS, meaning the bottleneck wasn't the algorithm thinking, it was the physical time fetching data from networked hard drives, hardware limitations.
So it sounds like they weren't just building a product that obviously became a huge one. They were building, like, a scientific instrument, a tool for understanding the web itself.
Precisely. That was a stated goal, to make Google a research tool. They explicitly mention its value for novel research activities on large-scale web data. And they said the data they'd gathered had already led to many other papers submitted to conferences and many more on the way. It wasn't just a search engine. It was this incredible resource, a necessary one, they said, for research into the web structure, its sociology, everything. It really opened up web science.
Okay, so clearly revolutionary. But being a good research paper, they must have also been honest about what wasn't perfect.
Yeah.
What were the limitations they acknowledged? Where did it still fall short?
Definitely. They were very upfront. The biggest immediate one was that search performance, the query speed. They admitted improving speed hadn't been the major focus up to that point. Their main goal was quality and the core system. So those 1/10-second query times, mostly due to disk I/O over NFS, were something they knew needed work.
Right. Even with all the smart software, the physics of spinning disks and network cables were the limiting factor. It really shows how hardware and software evolved together. They were pushing the absolute limits of '90s hardware.
Exactly. And related to that, they noted Google didn't yet have many common optimizations found in other search systems back then. Things they knew would help speed, like query caching, remembering results for common searches, or making sub-indices for really frequent words. They just hadn't gotten around to implementing them yet. The focus was on the radical new core, PageRank and anchor text. The tuning came later.
And the web itself, I mean, even their system couldn't perfectly tame that chaos, could it? It was still this wild, messy place.
Oh, absolutely. They called the web a vast collection of completely uncontrolled heterogeneous documents. Great phrase. Pages in different languages, formats, styles, huge differences in size, quality, popularity, and trustworthiness. Spam next to gems. Just crawling it was a challenging task with constant performance and reliability issues. Servers down, weird configurations, plus those social issues. It wasn't like indexing a clean, curated database. It was indexing, well, humanity's messy digital attic.
Yeah, like trying to organize that library where anyone throws in any book, in any condition, any language. Some are blank, some are lies. It's amazing they made any sense of it.
It really is. They also mentioned the complexity of the ranking function itself, combining all those signals, word position, font, caps, anchor text, PageRank into one score. It was difficult.
Yeah.
It involved many tunable parameters, lots of knobs to twiddle to get the balance right, and they were still working on a feedback system to help them tune it better. It wasn't a simple formula.
And that cool anchored text feature, finding uncrawlable stuff. Did it have any weird side effects?
A minor one, yeah.
Because anchor text could point anywhere, even to broken links or URLs that didn't exist yet. They acknowledged the search engine can even return a page that never actually existed if a strong link pointed there. It was an edge case they could mostly filter out by sorting, but it showed just how powerful and slightly weird the anchor text approach could be, a quirk of the system.
Okay, so they built this incredible foundation, acknowledged its limitations. What was next? What future did they see? What doors did this paper open?
Well, the immediate goals were very practical. Improve that search efficiency, the speed, and scale up. Their next target was approximately 100 million web pages. And they plan to do that by adding those simple improvements they'd skipped earlier: query caching, smart disk allocation, and sub-indices. Just basic engineering optimization.
Makes sense. Polish the engine. What about the content, the ever-changing web? How would they keep the index fresh?
That was a big research area. Updates. They needed smart algorithms to decide what old web pages should be recrawled and what new ones should be crawled. The freshness problem. You can't crawl everything all the time. You have to prioritize. They also mentioned exploring proxy caches to build demand-driven search databases, maybe index stuff based on what people are actually searching for, not just crawl blindly.
Interesting. And for users, what new features were they dreaming up beyond just faster, bigger search?
First, adding the basics that other engines had, like Boolean operators, and or negation, not stemming, finding related words like running, table stakes, really. But they were already looking much further ahead, exploring things like relevance feedback, where the system learns from your clicks. Also, clustering related results together, and even user context for personalization. Tailoring results based on who you are, maybe your past searches or location.
Wow. So even back in '98, they were envisioning search that wasn't just about keywords, but about understanding the user and their intent. That's basically predicting the next 20 years of search development right there, a truly intelligent assistant.
Pretty much. And their final vision in the paper, it's really telling. They hoped Google would be a resource for searchers and researchers all around the world, and that it would spark the next generation of search engine technology. They weren't just thinking about their own success. They wanted to push the whole field forward, build a legacy, not just a company. So, okay, you had to boil this whole thing down. The ultimate TLDR for our listeners on this incredibly important paper.
Right, the TLDR. I'd say this deep dive into Brin and Page's '98 paper shows the anatomy, literally, of a revolution. It took web search from just like basic keyword matching in this huge, messy, growing digital soup to a sophisticated system that actually understood relationships between pages. That was the key. By using the web's own link structure through PageRank and the descriptive power of anchor text, Google didn't just find more information. It found relevant, high-quality information. It found the good stuff at a scale nobody thought possible. It wasn't just bigger indexing, it was smarter indexing, understanding the network.
Couldn't say it better. And it absolutely set the foundation for how we access information online, even today. Decades later, the core ideas are still relevant.
Totally. And maybe here's a final thought to leave everyone with as we wrap up. The web is still growing, still changing, still kind of chaotic, right? New platforms, AI, massive data sets. If PageRank and anchor text were these sort of unused resources hiding in plain sight back in 1998, ready to be unlocked, what are the unused resources or the hidden structures in our digital world today? In social networks and AI models and all this data, what latent connections are just waiting for their own Brin and Page to see them, to figure out how to leverage them and spark the next revolution in information access? What's the next big insight hiding right under our noses?
That is a great question. Something to definitely ponder until our next deep dive.
For Computer Science Kick Paper Summary, I'm Alex.
And I'm Jordan. Hope you enjoyed digging into the origins of Google with us.